Okay, guys, so let's talk about lesson 6.6. It is more trig graphs. This time we're talking about tangent, cotangent, secant, and cosecant. So tangent, first of all, let's kind of go back to what tangent originally looks like. So here's our tangent graph. So this is my typical one. Typically it goes from negative pi over 2 up to pi over 2. That's kind of my period that's happening. And then it's going from 0 up to, I've got a 1 right here, and it just continues to go up. There's those asymptotes on either side. It goes down to -1 and then back down. Remember, this would be pi over 4, or negative pi over 4, sorry. That's where -1 is happening, and then pi over 4 is where 1 is happening. So just think about those types of things when we're thinking about these. All right, so typical setup with your A, B, C, and D. A this time gives us either a vertical compression or a stretch. So it's either going to kind of tighten it up or it's going to make it stretch longer. So really what that affects is this middle section, what's happening between this 1 and 0 and -1. That's either going to compress down or it's going to stretch out, okay? All right, again, if A is negative, you're going to see a flip over the x-axis. Your period this time is pi over the absolute value of b. So all those other ones were 2 pi over the absolute value of b. So this one's a little bit different. And then my phase shift is still my -c over b. And then remember, on those other ones, we had a lot of where it was like 0 to 2 pi. This one goes from negative pi over 2 to pi over 2. And again, that's because these asymptotes, that kind of marks my period there from negative pi over 2 to pi over 2. Okay, so this becomes really important in this problem. All right, so let's start out with this first one. They want me to graph this, and I'm starting with one that's a little bit more complicated because I don't want to have to do a lot of these examples. So I'm just going to start with a more difficult one, then the easier ones hopefully you'll be able to get through on your own. Okay, so this one, the first thing I'm going to start with is the period. I really want to know what's happening with those asymptotes, basically. All right, so typically it's pi over the absolute value of b for these. Okay, so pi over b in this case is a 1. So remember right here, b is in front of x. So that means I really have pi over the absolute value of 1, or just 1, which is pi. So my period in this case is pi. Typically it's more of a from negative pi over 2 to pi over 2, that is pi, right? So this is the same as what it normally would be anyway. So I'm not stretching or compressing at all. What else am I going to look at is this situation. So I'm going to do this idea right here. Negative pi over 2 is less than my bx plus c in this case is x plus pi over 4. So I'm going to subtract pi over 4 from each side. Okay, so that's going to make this a little bit weird. So this ends up 1/2 minus 1/4 is -3/4, or in this case 3 pi over 4. And then 1/2 minus 1/4 is 1/4, or pi over 4. So that means I've got a little bit of a shift here. That means my period is from -3 pi over 4. So this one's pi over 4 right here. This is negative pi over 2. So this right here would be -3 pi over 4. So 3/4 of the way to pi over there. So that's my starting asymptote. And then my ending asymptote would be pi over 4. So that would be right here. So I'm just counting by fractions here. So I could go through and mark all of my fourths. So this is 1/4. 2/4 is the same thing as a half. Here's 3/4. 4/4 is the same thing as pi, and so on, right? So marking those fourths in this case may be kind of important for this particular problem because it looks to me like most of my important points are going to happen at fourths. Okay, so here's how I do these problems. I know that my period is pi. So from here up another pi would be another asymptote. So right through here. And then another pi up would give me another one. And then down this direction, pi would give me another asymptote. So right here. Another way that you could think about it, if you have a hard time visualizing where pi is, how far away pi is, you could count from your asymptote to the next asymptote how many marks you're going. So I went 1, 2, 3, 4 marks. So 1, 2, 3, 4 marks again would be another one, and 1, 2, 3, 4 that way would be another one. That might make it a little bit simpler for you to think about. So the good thing about these is I don't have to think too much about my phase shift because I really just know that my middle point between these asymptotes is going to be on the x-axis. So looking back at this again, halfway between my asymptotes is that point on the x-axis. Same thing here. Same thing here. And then the other thing that I'm going to worry about is how far up or down is this value, right? So in a typical tangent situation, my A value, which sometimes we think about as amplitude, was just a 1. So 1 and -1. In this case, it's a 1/3. So I'm gonna be up 1/3 and down 1/3 of the way. So that's one way to think about it. Okay, so in this one, the middle of this would be right here. That'd be the middle of that one. The middle of this one would be right here. The middle of this one would be right here. So that gives me my middle points. And then again, like I said, this A value is 1/3. So I'm going to go 1/3 of the way up. So if this is 1, here's a half. 1/3 of the way up would be like right here. And 1/3 of the way down would be over this direction. So on this one right here, I'm going 1/3 of the way down. So what's going to happen is these three kind of get connected almost linearly. It's interesting how that happens. And then it kind of curves up and it curves down this direction. Now, if this 1/3 would have been negative, or if I would have had negative in the middle here, that would cause me to make it flipped, right? So this would then go up this direction and down this direction. But this one's a pretty typical, safe, easy one. So let's see, about 1/3 of the way up, about 1/3 of the way down. Connect those up and down. Oh, I didn't put that in the right place, sorry. Thought that looked a little odd. I missed my 4th mark right there. That's better. Okay, and then over here, same thing. So here's 1/3 of the way down, 1/3 of the way up. Okay, so there's my tangent graph. I could do another one over here if I wanted. Usually if you have 3 of them, you're good to go. All right, so then let's talk about cotangent. What happens there? Well, in a cotangent situation, everything is the same as tangent, except now this kind of period, instead of going from -pi/2 to pi/2, cotangent goes from 0 to pi. So it's kind of shifted over from 0 up to pi. And that's without a phase shift. So you may just want to take a look at that, but those otherwise are the same. You would do the same thing here. The difference is you're going to use this to start with, figure that out, and then put your asymptotes according to that. Still though, checking the middle, checking your A value to tell where those other 2 points on the outsides are, and then draw it in. You should be good to go. Okay, secant and cosecant. These are, again, very similar. You still have a period, a phase shift, and these look very similar as sine and cosine. They look very similar to those because it's 2 pi over b again. But again, check this part right here to find those asymptotes where it's going to happen. And I really like this image for these. So this right here is this dashed line is your sine curve, okay? So let's pretend like that is a graph of just sine of x. Your cosecant, which is 1 over sine, is these parabolas above and below those. So it kind of connects to those points, but it's always above and below it. So same thing with secant. Secant is the 1 over cosine situation. So here's my cosine curve, and there's your secant parabolas. Okay, so that kind of gives you an idea of what those will look like in general. Okay, so let's look at this one right here. I've got 2 secant of x minus pi over 4. So I'm going to start again with the period. That's the first thing I really want to think about here. In this case, I've got 2 pi over the absolute value of b is what that is. So in this case, it's 2 pi over 1 again. So I picked a couple that were just 1s right there. So I'm not squeezing it in or extending it outward. It's still just a period of 2 pi. And then I'm going to look at, so typically, this one's a secant one. So typically a secant would go from negative pi over 2 up to 3 pi over 2. So let's see what happens with this one if it's any different. So negative pi over 2. And then I'm going to use my bx plus c, which is x minus pi over 4. And it goes up to 3 pi over 2. So again, I'm using this, 3 pi over 2. So now I'm going to add my pi over 4 to both sides, or all sides, I guess I should say. All right, so that's going to give me, in this one, a negative pi over 2 plus a pi over 4. So this is like negative 1/2 plus 1/4 would be negative 1/4, or negative pi over 4. And then 3/2 plus another 1/4. So this is the same thing as 6/4 plus another 4th would be 7/4. Okay, so that means my phase shift, if I think about this, if it's typically from negative pi over 2 to 3 pi over 2, and now it's negative pi over 4 to 7 pi over 4, that means I shifted a 4th. So pi over 4 is my shift, if you wanted to think about that, or you could calculate it as negative c over b. So I'm just going to write in my asymptotes first. So from negative pi over 4, so let's find that one. So right here's negative 1 pi over 4, negative 1/4. Okay, so there's negative 2/4, negative 3/4, negative 4/4, and so on, right? So I'm going to use my fourths again. This direction I've got 1/4, 2/4, 3/4, 4/4, right? I need to go all the way up to 7/4. So there's 4, 5, 6, 7/4 is right here. Now this one is interesting because on these, a period is actually considered to have both a upward parabola and a downward parabola. So if I'm looking at this one, one period would be one parabola that's going upward, one parabola that's going downward. So from negative pi over 2 all the way up to 3 pi over 2. So if you notice, there's another asymptote right in the middle. So I'm going to draw that one in as well. So if I count 1, 2, 3, 4 of them over, and 1, 2, 3, 4 from this direction makes this one my middle, there's another asymptote right there. Okay, so then I'm going to draw in my parabolas. So remember, A is 2 in this case. So if A is 2, here's my 2, and here's my negative 2. So typically then my cosine wave would be going through like this middle section. So my parabolas are going to touch these 2's, but they're going to go upward and downward. So in this first one, if my phase shift was a positive pi over 4, that means my first one is just shifted over a tiny bit this direction and it's going upward. So at 2, in the middle of this section, again, I'm going to find my middle, which would be right here. That's the vertex of my parabola, and it's going up this direction. Now I could be much more strategic than that and come up with these outside points, but honestly, it doesn't matter that much. I'm not too stressed about that. My second one would be down here, find the middle, That's where your vertex is at -2 in this case, and then it's going downward. So if I wanted to make more, I could go over to the next set and go down here, do my next one, and up here, do my next one. So let's find where that asymptote would be. So remember, there's 1, 2, 3, 4 between my asymptotes. So 1, 2, 3, 4. There's another one right here. I feel like once you get 1 or 2 of those parabolas drawn, it's pretty easy from there. So the middle of that one, and then here's my parabola going downward. And then over here, 1, 2, 3, 4, that would be another asymptote right there. And then up from 2 in the middle would be my next parabola. So there's not too much stress on this one about phase shift. It's just finding where those asymptotes are and then finding your middles. I feel like that's the easiest way to do it. And then don't forget about A, kind of creating that almost like a horizontal asymptote, because that's where your sine or your cosine curve would be in the middle. Okay, so cosecant is very similar to that. Just watch that one as far as where your asymptote should be. So pay attention to this if you get a cosecant one.